Hello friends, in last lecture we saw up to this, that is Miller indices of some planes. Here this plane intercepts along x-axis and it is parallel to y and z-axis. Therefore, Miller indices of y and z-axis becomes 0. And it intercepts along x-axis, therefore Miller index of x-axis is 1. That is 1, 0, 0 are the Miller indices of this given plane. Then we have to find out Miller indices of this plane. This plane is parallel to c-axis. Also it is parallel to a-axis. But it intercepts b-axis here. Therefore Miller index of b-axis, that is k, is 1. या ठिकाणी दाखवलेला आहे. आणि ए चा आणि सी चा म्हणजे एच आणि एल काय होतील, 0 होतील. ओके, त्या प्लेनचे मिलर इंडायसेस 0, 0, 1. कसे? तर हे प्लेन ए ऍक्सिस ला पॅरलल आहे, ए ऍक्सिस ला पॅरलल आहे. बी ला सुद्धा कसं आहे, हे पॅरलल आहे. आणि सी ला काय होतंय, सी मधला इंटरसेप्ट होतोय. त्यामुळे एल इंडेक्स काय आहे, 1 आहे, बाकीचे दोन 0. हे तिन्हीला इंटरसेप्ट करतात एक्स वाय झेड ऍक्सिसला. त्यामुळे याचे मिलर इंडायसेस कसे आहेत, 1, 1, 1. वी हॅव टू फाइंड आउट मिलर इंडायसेस ऑफ दिस प्लेन. ओके, हे प्लेन कसं आहे, ए ऍक्सिसला इंटरसेप्ट करताय, ए टू ए. बी ऍक्सिसला कसं आहे, पॅरलल आहे. तसंच हे सी ला पॅरलल आहे. देअरफॉर बी चे आणि सी चे मिलर इंडायसेस, दॅट इज के आणि एल काय होतील, 0 होतील. आणि एच म्हणजे ए ऍक्सिस वरचा काय होईल, 1 होईल. Therefore, Miller indices of this plane is nothing but 1, 0, 0. 1, 0, 0. Miller indices of this plane हा B ला इंटरसेप्ट करतोय, A ला आणि C ला कसा आहे, पॅरलल आहे. Therefore, Miller indices of this plane are nothing but 0, 1, 0. Miller indices of this plane याच्यासारखाच आहे, 1, 1, 1. Miller indices of this plane हा काय होतोय, A ला आणि बी ला इंटरसेप्ट करतोय. त्यामुळे एच आणि के 1, 1 होतील. आणि सी ऍक्सिसला कसा आहे, पॅरलल आहे हे प्लेन, म्हणजे एल काय होईल, मिलर इंडेक्स 0 होईल. म्हणजे याचे मिलर इंडायसेस 1, 1, 0. दिस अबाउट दॅट इज मिलर इंडायसेस. ओके, पूर्वी शॉर्ट नोट असायची, मल्टिपल चॉईसला तुम्हाला विचारलं तर तुम्ही लिहा. नाउ वी सी नेक्स्ट पॉइंट, दॅट इज इंटरप्लेनर स्पेसिंग, denoted by the symbol small d. You see here interplanar spacing. This is figure. This is consider one of the reference plane passing through origin O and another plane ABC, which cuts the intercepts along x, y, z axis at A by h, B by k, and C by l. Consider reference plane which is passing through origin O. Also consider another plane which intercepts along x, y, z axis at A by h, B by k, and C by l, shown here in this figure. Then draw normal from origin to the plane ABC, which represents interplanar spacing D. Which represents interplanar spacing D, and we have to find out in this lecture the value of D, that is interplanar spacing D, which is also known as distance between two adjacent planes. This is a reference plane and another plane kutla ABC. These are the adjacent planes, and D represent, that is interplanar spacing, represents distance between two adjacent planes. Okay, let OX, OY and OZ are the orthogonal axes. Now consider any set of crystal planes having Miller indices HKR. The reference plane passes through origin O and the next plane ABC, which cuts the intercepts at A by h, B by k, and C by l along x, y, and z axis respectively. Normal OP is drawn to the plane ABC from origin. The length t from origin to plane gives the distance between adjacent planes, known as interplanar spacing. Okay, then from triangle OPA, OP आणि हा A, from this triangle OPA, angle किती आहे, O जवळचा अल्फा आहे. From triangle OPA, cos of alpha लगतची बाजू डिवाइडेड बाय कर्व. cos of alpha लगतची बाजू किती आहे इंटरप्लेनर स्पेसिंग डी आहे OP डिवाइडेड बाय कर्व A by OA, that is A by H. cos of alpha equal to OP divided by OA, OP's value, and D divided by OA, A by H can be written as DH by A. Can be written as DH by A. Similarly, from triangles OPB, OPB, मधला अँगल, ओके, बीटा कन्सिडर करा, and OPC हा वरचा अँगल gamma consider kara and find out cos of beta and cos of gamma. Therefore, similarly from triangles OPB and OPC, get what? Cos of beta equal to dk by b and cos of gamma equal to dl by c. कसा cos of beta काढला? cos of beta हा मधला ट्रायंगल, ओके, OPB हा ट्रायंगल कन्सिडर केला. अँगल कुठला? हा O जवळचा हा अँगल कन्सिडर करायचा. सपोज हा cos बीटा कसा करायचा? OP डिवाइडेड बाय OB किती आहे? B बाय K कर्ण आहे आणि डायगोनल. OP किती आहे? D आहे, दॅट इज D डिवाइडेड बाय B बाय K म्हणजे DK बाय B आला, DK बाय B. तसाच cos of gamma कसा काढायचा? Consider another triangle OPC. हा अँगल कन्सिडर करायचा गॅमा च्यावरून व्हॅल्यू काढायची आहे आपल्याला. cos of gamma इक्वल टू OP डिवाइडेड बाय OC. OP किती आहे? D डिवाइडेड बाय OC किती आहे? C by L. D डिवाइडेड बाय C by L is nothing but DL by C. Therefore, cos of gamma equal to DL by C. Also, we know that cos square alpha plus cos square beta plus cos square gamma is nothing but 1. Put out the value of cos alpha, beta and gamma. Cos alpha's value dh by a. चा स्क्वेअर करा, d square a square by a square plus cos beta ची dk by b म्हणजे कसं होईल? d square k square by b square plus d square l square by c square equal to 1. सगळ्यात कॉमन d स्क्वेअर आहे, कॉमन कडा d स्क्वेअर इंटू ब्रॅकेट a स्क्वेअर प्लस k स्क्वेअर बाय b स्क्वेअर प्लस l स्क्वेअर बाय c स्क्वेअर इक्वल टू 1. Therefore, d स्क्वेअर इक्वल टू 1 divided by h स्क्वेअर प्लस a स्क्वेअर बाय a स्क्वेअर प्लस k स्क्वेअर बाय b स्क्वेअर प्लस l स्क्वेअर बाय c स्क्वेअर. Therefore, d इक्वल टू रूट घ्या h स्क्वेअर बाय a स्क्वेअर प्लस k स्क्वेअर बाय b स्क्वेअर प्लस l स्क्वेअर बाय c स्क्वेअर रेस टू मायनस हाफ वरती घेतला आपण. याचं रूट काय होईल? 1 divided by root of h square by a square plus k square by b square plus l square by c square. हा रूट वरती घेतल्यानंतर काय होईल? मायनस हाफ होईल. म्हणजे d ची व्हॅल्यू काय आली? h स्क्वेअर बाय a स्क्वेअर प्लस k स्क्वेअर बाय b स्क्वेअर प्लस l स्क्वेअर बाय c स्क्वेअर रेस टू मायनस हाफ. Therefore, for Miller indices HKL, this interplanar spacing D can be written as DHKL equal to h square by a square plus k square by b square plus l square by c square raised to minus half, that is equal to 1. So this also can be written as DHKL equal to 1 divided by root of h square plus a square plus k square by b square plus l square by c square. कसे लिहा? 1 divided by root लिहा किंवा this raised to minus half लिहा, which is suppose equation second. Equation first. This equation first gives interplanar spacing. Interplanar spacing, that is DHK equal to h square by a square plus k square by b square plus l square by c square raised to minus half of 1 divided by root of this. Okay? If we have given cubic structure, that is we have to find out the value of DHKL for cubic structure or the value of interplanar spacing for cubic structure. Cubic structure ची कंडिशन काय? A equal to B equal to C. तिन्ही बाजू सारख्या असतात. Then by using this condition, cube ची condition A equal to B equal to C. Therefore, by using this condition, DHKL for cubic lattice can be written as DHKL equal A. Okay? आता काय होईल? A. That is इक्वेशन कसं होईल? हा A divided by h square plus k square plus l square raised to half. A divided by h square plus k square plus l square raised to half. Okay, dhkl equal to h square plus a divided by h square plus k square plus l square raised to half, which is equation second. That is the interplanar spacing or cubic structure. This is about that is interplanar spacing. Okay. Then we see next point or last point from the chapter, that is some crystal structures. We have to study the crystal structures such as hexagonal closed packed structure, then second FCC, that is face centered cubic structure, then BCC, that is body centered cubic structure, and last simple cubic structure. Okay, these structures can be studied or explained by using their coordination number, packing fraction, and atomic radius. Such structures can be described with the help of their coordination number, packing fraction, and atomic radius. First, we see the definition of coordination number. Coordination number, as far as the chemistry, coordination number can be defined as the number of nearest neighboring atoms in the crystal. Coordination number can be defined as the number of nearest neighboring atoms in the crystal. Okay, as greater be the coordination number, then more closely packed will be the given crystal structure. Multiple choice ला लक्षात ठेवायचं. Definition किंवा जर coordination number जास्त असेल तर given structure कसं असतं, more closely packed असतं. That is, as greater be the coordination number, then more closely packed will be the given crystal structure. Then we see about packing fraction. Packing fraction, or it is also known as packing density. Packing fraction, the ratio of volume of number of atoms per unit cell to the volume of unit cell. Right? Ratio of volume of atoms per unit cell to the volume of unit cell is known as packing fraction or packing density. As larger be the packing fraction, then more closely packed will be the given structure. Then we see about radius, atomic radius r, denoted by the symbol small r. It is defined as half of the distance between nearest neighboring atoms. Atomic radius can be defined as multiple choice ला लक्षात ठेवायचं, half of the distance between nearest neighboring atoms, and it is always given in terms of cubage A. It is always given in terms of cubage A. Okay. Then we see first structure, that is hexagonal closed packed structure. Okay, that is SCP structure. The SCP structure is a closed packed structure because each atom has 12 nearest neighbors. SCP structure is a closed packed structure because each atom has 12 nearest neighbors. Therefore, SCP structureचा coordination number किती होईल? 12. Coordination number is nothing but number of nearest neighboring atoms. आणि या स्ट्रक्चर मध्ये nearest neighboring atoms किती असतात? 12 असतात. त्यामुळे SCP structureचा coordination number 12. Therefore, SCP structure is a closed packed structure because each atom has 12 nearest neighbors. Therefore, coordination number of SCP structure is 12. Okay. In SCP structure, atoms are arranged in 3 layers. In SCP structure, atoms are arranged in 3 layers. In one layer, each atom is in contact with 6 atoms, and in other 2 layers, each atom in contact with 3 atoms. Therefore, in this structure or in SCP structure, atoms are arranged in stacking sequence of ABC, ABC, and AB, AB, AB. Okay. In SCP structure, atoms are arranged in stacking sequence of ABC, ABC, and AB, AB. This can be shown in the following figures. Okay. Multiple choice ला हे वाक्य आलं तर तुम्ही लिहा. But in this structure, each atom in contact with 3 other 3 atoms, that is, they are in a stacking sequence of ABC, ABC, and here each atom in contact with 6 atoms here, and here 3 atoms. Okay, that one figure.